Next problem we're looking at is this here, 3 e to the x minus 4 equals 8. So when we solve any of these here, and this even goes with the next set that we have, we want the term with our variable by itself. So either be that e to the x, or if we have a log with x inside of it, we want it by itself. So here, the first thing we need to do is get it by itself. So we would add 4 to both sides, telling us 3e to the x is equal to
what? Oh.
12, because we're adding 4 to both sides. Now what would we need to do next? We're going to divide both sides by 3. And when we divide both sides by 3, we'll have e to the x is equal to 4. Questions on how we got our e to the x by itself? Okay. Now we need to get the x out of the exponent now that we've got it by itself. And we can do that by applying a log to both sides. Specifically, what log will we apply to both sides? The natural log, yes. Because the natural log's base is understood to be e. And that's helpful for us because ln of e to the x, ln of e simplifies to 1, leaving us with just x. Because the x moves to the front, and our x times the natural log of e is just x times 1, which gives us x. Is equal to the natural log of 4. Now, if we want to find out what the approximate value of the natural log of 4 is, we can grab a calculator and say ln of 4. Hit enter, and it'll tell us that it's 1.386294361, or 1.386. But, especially on the test, and this goes for the homework too, I'm going to take x equals ln of 4. Especially on the test, that's as far as I want you to take these, because if it doesn't have a nice answer, we're having to approximate it. No, you don't have to put the 1.386. That's fine. And the reason I say that, especially for the test, going from here to here is not really showing your ability to solve these. It's just showing your ability to plug it into a calculator. And I mean, for this here, it's not bad. When we had some for the other day, we had x is equal to log base 6 of 311 minus 4 all over 7. That's a lot to plug in and making sure we get it right. That's the answer. I solved it. Anything beyond that's just plugging it in. So, again, that's as far as I'm going to have you take it. Okay? We're ready for the next one. E to the 4x minus 3 is our e, our base, with the variable and the exponent by itself. So what's being added or subtracted from it? Multiplied by it? Or divided? Nothing. Because the 4x minus 3 is in the exponent, yes? So e is already by itself. It is by itself, so we just need to apply a log to it. And specifically, we're going to apply the natural log to both sides. Now on the right-hand side, the natural log of 19 as well as the natural log of 19. Now, if that turned out to be a nice number, then we would simplify it. But unless what's inside the natural log is e, it's not going to simplify to a nice number. Now, the other side, the natural log of e to the 4x minus 3, is it?
4x minus 3.
It's going to become 4x minus 3. Because the natural log of e is 1. And really what we're doing is we're moving the exponent to the front and then multiplying it by the natural log of e, or just multiplying it by 1, giving us 4x minus 3. And we did that to get the x out of the exponent. Because once it's out of the exponent, we just need to solve for x. And our next step would be to add 3 to both sides. On the left-hand side, we'll just have 4x because our negative 3 plus 3 is 0. The right-hand side will have the natural log of 19 plus 3. And last but not least, divide both sides by 4. Telling us x is equal to the natural log of 19 plus 3 divided by 4. And that's it. Questions on this here? We're ready for the next one. Log base 2 of 5x minus 17 equals 3. So this is a little bit different because we aren't given a base and then a variable in the exponent. Now we're given a variable inside of a log, yes? Now on the previous ones, we used logarithms to undo exponents. So what do you think we're going to use here? We're going to have to use properties of exponents. Because if a log doesn't base with an exponent, a base with an exponent should undo a log. So what base do you think we should use?
I have no idea.
It's actually written up there. 2. Because 2 to the log base 2 would simplify out. Because this goes back to our property that b to the log base b of x is x. B to the log base b of x is x. So if I put this one side to the base of 2, the 2 in log base 2 cancels, leaving us with 5x minus 17. But if we do it to one side, we have to do it to the other, which is just telling us that 5x minus 17 is equal to 2 to the third power. Questions on this here? Now, is 2 to the third power a nice number? What is 2 to the third? It is not 6.
I don't know. 9?
2 to the third power is
8. Oh,
yeah, because we're saying we're multiplying 2 by itself 3 times. Well, now we just need to solve for x. Our next step would be to add 17 to both sides. We add 17 to both sides. These simplify out, and 18 or 8 plus 17 is 25. And last but not least, we would divide both sides by 5, telling us x is equal to 5. Now there are some restrictions on x, but it's really what's inside the log, our 5x minus 17. We cannot have it be 0 or a negative, because if whatever value of x, when plugged back in there, gives us 0 or negative, it doesn't work. Now if we want to, we could check this. I could say log base 2 of 5 times 5, our value of x, minus 17. I just plugged it back in. Plugged 5 back in for x. Now our 5 times 5 is 25. 25 minus 17 is 8. So our number here is not 0 or a negative, yes? So it works. And if we wanted to fully check this, we could then plug this into a calculator, and it will tell us it is indeed 3. So it does work. Questions on this here? Let's look at the next one. Log base 3 of 10x minus 9 equals 4. What would we do first? We would put both sides to the base of 3. Because our 3 to the log base 3 of 10x minus 9, the 3 in log base 3 would cancel, giving us 10x minus 9 equals 3 to the 4th power. Now 3 to the 4th power again is a nice number. 3 to the 4th is 81. What would we do next to solve for x? Add 9 to both sides. Plus 10 to the x is equal to 90. And lastly, we would divide both sides by 10. And that's it. Now, luckily for us here, this will work, where you won't have any real restrictions on these here. But the real place or real thing to check for restrictions is just making sure this value of x will not make 10x plus 9 or 10x minus 9 be negative, yes? So if I wanted to, I could take 10 times 9 minus 9, plug it in a calculator and see what I get. It tells me it's 81. That's a positive number and it's not 0, so it works. Because if it gave me negative 81, we know that value doesn't work and we throw it out. That's it. Questions on this here? Last one. We'll put both sides to the base of 2. Now our 2 to the log base 2 would cancel, leaving us with is equal 5th power. Now we could plug that in a calculator and get 32. At this point we would add 6, telling us x is 38. And that's it. I mean, we could have other things inside the log. I mean, we could have a quadratic and different things. That doesn't really change it. It just means we have to solve a quadratic like we've done before. Questions on this here? We're ready for the next piece. That's it. You have the rest of the class time to work on the assignment.